All right, we are on our last shape in our volume unit, and this happens to be a sphere. And there's lots of spheres like basketballs and baseballs that are out there in the real world. Sometimes big oil tanks are shaped like spheres, bowling balls, and sometimes it's helpful to know how much the volume of a sphere is so that we can figure out how many we can make if we have a certain amount of a substance. So the volume of a sphere, when we're talking about spheres, we're going to use the volume of a cone or of a cylinder to help us come up with a formula for the volume of a sphere. And just imagine that you have a sphere that's got the same height as a certain cylinder that it may be sitting in, and the radius would be the same, and the height of the sphere in this case would be equal to the amount of two radiuses, right? See how that's the same distance? So when we do a little bit of work and come up with a formula, we come up with this is our formula for the volume of a sphere. So 4/3 times pi times the radius cubed. So let's practice a few of these, just kind of get good at it and see what we can do. So for our first one, we've got a sphere that has a radius of 4. So when we get it into our formula, it looks like this: 4/3. We're going to use 3.14 for pi, and then 4 to the third power. And then when we get it in our calculator, it looks something like this. And when we multiply it out, initially it is 267.9466667. So this is the case where you have a repeating decimal, and at the end of the calculator display, they rounded that last digit up to a 7. But we're just going to round this one to the nearest tenth. We could have rounded it to the nearest hundredths, whatever, but in this case we just rounded to the nearest tenth and called it good. So 267.9 cubic centimeters, so centimeters cubed. All right, on our next one, here's the next one on our guided notes. The volume is, once again, 4/3 pi r cubed. So when we put it on our formula, we have 4/3 times 3.14 times 3 to the third power. And when we hit enter on our calculator with that formula in there, it comes out to be 113.04 centimeters cubed. There's the cm up there. And this is what it came out to be. There was no rounding before I did this. So that should be accurate enough. We'll just leave it rounded to the nearest hundredths in that case. Okay, so let's take a look at another one. In this one, we actually have a basketball that has, or it can't be a basketball, it's a very big giant ball of some kind that has a diameter of 16 feet, which is quite big. So when we put it in our formula to find the volume, we have to take that diameter. Oh, if you think about it, that diameter should actually be 8, or the radius should actually be 8, shouldn't it? So you got to make sure you don't run into a problem right there. So I'm going to put an 8 in there, and this should be 8 cubed, shouldn't it? So then, when we go to our answer page, we'll have to take that into account. So if I go to the next page, I should have put 8 to the third power right there on the calculator, huh? So if I do that, I'm going to do that off screen here. So 4, fraction key 3, parenthesis, 3.14, parenthesis, and then another parenthesis, and then 8 cubed. So this should be 8 cubed. And when I hit enter, I end up with 21. So we're going to cross that off. It's going to actually be 2143.6, and we rounded it. 0.6 cubic feet, so feet cubed. So hopefully you didn't put in too much extra writing when I threw you off there, but that should have been an 8. So watch out for that. When you have this diameter, sometimes people just put in the whole diameter and forget to turn it into a radius. So make sure you watch out for problems like that. Let's take a look at the next one and make sure I did that one right. All right, so in this case, we got a ball that's, or more like a marble, that's 18 millimeters diameter. So when we put that into our formula, we are going to just use the radius, which is 9, and we've got that accurately portrayed over here. And so when we did that on the calculator, we ended up with 3,052.08 cubic millimeters for a ball that big, which is quite a few cubic millimeters, isn't it? Okay, now we're going to get to be more real life here. Dion's company makes solid spheres out of scrap metal for various industrial uses. Now, if you've never seen steel balls or aluminum balls like this, they quite often use them for bearings that they can use to hold up big cars and trucks and have the wheels roll comfortably and without a lot of friction. So in this case, we actually have a radius of 7.5 inches, and we want to know how much it's going to cost to make one of these bearings. So we're going to put our formula down. That's 4/3 times 3.14 times 7.5 cubed, which will give you the volume of one of these big silver spheres. And then we're going to multiply that by 0.36 to find out how much it would cost to make one sphere. So when we crank the numbers, we end up with $635.85. So kind of fun. So if you are making something like this and you can figure out the unit price, you can calculate how much the overall project's going to cost you before you even do it to make sure that it's going to be worth your trouble. Okay, on this last problem, we're talking about candy now. So the company makes chocolate candies in the shape of a solid sphere. Each piece of candy has a diameter of 6 centimeters. If the box contains 20 pieces of candy, how much chocolate does the box contain? So when we put that in our formula, we've got 4/3 times 3.14 times 3 cubed, because we have a diameter of 6, so the radius is 3. And then we're going to multiply it by 20 to find out how much is in 20 chocolates, right? And so when we do that, we end up with 2,260.8 cubic centimeters of chocolate. And so when I say 8 cubed, I'm talking about like that. Actually, I think we do have one more, don't we? The company makes wax candles in the shape of a solid sphere. Suppose each candle has a diameter of 15 centimeters. Uh-oh, there's a diameter. Hopefully when I did this, I used the radius. If the company has a total of that much wax, how many candles can be made? So what we do, first of all, is find out how much wax is in one sphere, right? So you make a candle, and you find out how much is in there. And so it turns out to be 1,766.25 centimeters of wax in one candle. Now you take the total number of cubic centimeters of wax we have and divide it by the amount in one candle, and that will tell you how many actual candles we can make. And when we did the numbers, it comes out to be 20 centimeters cubed. Well, 20 candles, because there are 20, the candles are each in cubic centimeters too, but this is how many of these candles you can make with that much wax. All right, you get the idea? So we're going to do number 106, volume of spheres on Alex. Remember to show your work and to use those formulas, and good luck. Thank you very much.